Section 4.3 and 4.4. Factoring trinomials in the form of ax squared plus bx plus c, and more factoring by grouping. Factoring trinomials in the form of ax squared plus bx plus c. In this section, we'll be learning how to factor trinomials in the form of ax squared plus bx plus c, meaning the coefficient on x squared is bigger than 1. Basically, that means that the number here, whatever it might be, is bigger than 1. Whenever that's the case, we must use the ABC method to factor trinomials. So we'll take a look at some of the examples on the next slide. But first, let's do the breakdown of what the ax squared plus bx plus c, or the ABC method, entails. It's the product of a times c, and the product of a times c must give you the sum of b. So basically, you need to find two numbers when multiplied that will give you the product of a times c, but those same two numbers must add together and give you a sum of b. Here's your first example. Factor 5x to the second plus 27x plus 10. Where here, your a is 5, your b is 27, and your c is 10. You can obviously see that a is bigger than 1, so therefore we must apply the ABC method. So it's the product of a times c, 5 times 10 is 50, to give me a sum of b, which is 27. So over here you see I've listed the multiple ways of multiplying two numbers that will give me a product of 50, but will give me a sum of 27. If you take a glance at the sets that I've listed here, you see the correct pair would be a positive 2 and a positive 25. Now, what do you do with those two numbers? Okay, taking those two numbers, you must rewrite 27x using those two numbers. So 27x now becomes 5x to the second plus 2x plus 25x plus 10. Now, if you notice, by doing the ABC method, I've just created 4 terms. Now, think back. What method did we use when we had an expression that had 4 terms in it? And how did we factor it? Well, we have to use what's called factor by grouping. So here's a helpful note for you here. The ABC method, if done in this way, will always turn into factor by grouping. So step 1 of the process says you group the two terms together that are in the front and the two terms that are together in the back. Remember that the sign in the middle goes on the outside. Step 2 says find a GCF for each individual section. So for the first two terms, the GCF will be x, which means I'm dividing by x if I need to. So if I did so, I'll be left with 5x plus 2 plus the GCF for the second two terms will be 5, but no x's because there's not enough in common to take out any. So if I take a 5x, which means I'm dividing by 5 technically, I'm left with, again, 5x plus 2. Step 3 says if there's a common binomial factor in common, factor that out, and what remains is put together, which is the x plus 5 will go together. Here's another example. Factor 3x to the second plus 4x minus 5. Here a is 3, b is 14, and c is a negative 5. So if I apply the ABC method, I need to do a times c, which will give me negative 15, and I need to get a sum of b. B is, again, 14. So if you take a quick look at some of the ways I've multiplied two numbers that will give me negative 15, that might give me a sum of positive 14, you can see the numbers that I'm going to choose to use are going to be a negative 1 and a positive 15. We're going to go and rewrite those in terms of x. So 14x is now rewritten to be 3x squared minus 1x plus 15x minus 5. Once again, this creates 4 terms, which means we have to factor by grouping. So step 1 of the process says we group them. Step Step 2 of the process says we find a GCF for each section, starting with the first section. That would be x. So if I factor out an x, I'm left with 3x minus 1 plus second section, the GCF is 5. If I factor out a 5, that means I'm also left with 3x minus 1. Step 3 of the process says if there's a common binomial factor, which there is, we take that out, and what remains is put together, which is the x plus 5. Section 4.5, factoring the difference of two squares in the form of a squared minus b squared. Factoring the difference of two squares in this section, we will be learning how to factor a special type of binomial known as the difference of two squares. Well, how do you know if a binomial is indeed the difference of two squares? Well, see the requirements in the format below and see the examples on the next slide. Step 1. The first and second term must be perfect squares, meaning there exists a variable or a number multiplied times itself twice that will give you those terms. Step 2. There must be a subtraction sign, hence the word difference or minus and plus. Step 3. If the first two steps are met, then you can factor the binomial as such. The difference of squares is known as a to the second minus b to the second, and factors as a minus b and a plus b. Now, what is not known as the difference of squares is a squared plus b squared. That does not equal a minus b and a plus b. Remember, one of the requirements for the difference of two squares says you must have a minus sign in the middle, not a plus sign in the middle. Please do not get these two mixed up, because if you do, it's going to cause a problem, which means you're going to factor incorrectly and you're going to be marked off and penalized for that. That is called prime. It does not have an answer at this level, and the next level it does, but at this level it does not factor. We call it prime, or no solution, no answer, can't be done, however you want to say it, but there is no answer. There's no such thing as the sum of two squares, only the difference of two squares. Factor x to the second minus 9. Does this meet the requirements for the difference of squares? Step 1. Yes, it does. X to the second is just 2x's. 9 is a perfect square. Why? Because 3 times itself 2 times is 9. So that's the case. I can do x 3 minus plus or plus minus. It does not matter to which order the signs come in, but you must have them both. Does this meet the requirements for the difference of squares? Yes, it does. Why? Because the first term is a squared, which is 2a's, and 16 is a perfect square because 4 times 4 is 16. If that's the case, then that means I can do this. A here, a there, 4 here, 4 there. Once again, minus plus or plus minus. It does not matter the order to which you put the signs in, but you must have them both. Section 4.6, solving quadratic equations. Now, when you factor a trinomial, sometimes it'll be set equal to 0, which means it wants you to factor and also solve. This is called the zero factor theorem, which basically allows you to set the factors equal to 0 and then solve for the variable. First example, here you have two factors. One is x, the other is 2x minus 5. You're going to individually set them both equal to 0. Now, x equals 0 is just that. X equals 0. You cannot do anything beyond that, so that's your first result, x equals 0. However, 2x minus 5 set equal to 0. This is a two-step equation that you need to solve for. So first step, you're going to add 5 to both sides. The 5's on the left cancel. 2x equals 0 plus 5, which is 5. Final step to solve for x, divide both sides by 2. The 2's on the left cancel. X equals 5 over 2. So your answers here are x equals 0 and x equals 5 over 2. Here you have two binomial factors, okay, which means this problem was already factored for you. So all you need to do here is set them individually equal to 0 and solve for the variable. So on the first factor, you're going to add 7 to both sides. X equals 7. And on the last factor, you're going to subtract 2 on both sides. X equals negative 2. Same process here. Set both factors equal to 0. And then solve for the variable. First factor, add 10 to both sides. X equals 10. Second factor, subtract 1 on both sides. 3x equals negative 1. Divide both sides by 3. X equals negative 1/3. Here, you're going to have to factor using the BC method. B is negative 9 and C is negative 22. Remember, with the BC method, you can automatically break down your parentheses. The numbers we're going to use here are going to be 2 and negative 11. So you're going to have x here, positive 2, negative 11. Solve for the variable by setting them equal to 0 individually. So subtract 2 on the first factor, x equals negative 2. Set the second factor equal to 0, add 11 on this one, both sides, x equals 11. This is the difference of squares, okay? It says factor and it also says to solve. So we're going to factor this because we recognize this is the difference of squares. The first two terms are squares. A to the second is 2a's, and therefore 16 is 4 times 4, making it a perfect square. So that means this factors in the following way. Set them equal to 0. On the first factor, add 4. A equals 4. Second factor, subtract 4. A equals negative 4.